here to get an understanding and be trained about SCOR, right? So we are here for SCOR, and what this is all about is implementing and operating security core technologies, okay, for Cisco. So this is all about implementing and operating Cisco security core technologies. So as such, as the name suggests itself, this is a core uh, certification, right? It's a core examination certification. Now, what does this mean? Okay, this is not a concentration examination. That is what it means. Okay, so generally, what you have is even with various CCNP stuff. Yeah, I mean, of course, this is a CCNP level certification, right? That uh, is something that you need to understand. Now, following this, meaning once this is done, okay, what you can opt for is something which is concentration examinations. So what does this mean? So SCOR basically is all about the entire landscape of Cisco providing different stuff. Okay, so as you will learn that Cisco does provide you with a lot of things. There is something called as the ASA. There is something called as the firepower devices. Okay, there is ESA, there is WSA. Okay, and there's ICE. Okay, so various stuff provided under the Cisco umbrella, okay, of technologies. In SCORE is we basically look into the basics of everything, how to get things up and running, okay, how to like understand the basic working of stuff. Now, once like this certification or this examination or training is done, what you could then opt for is some concentration examinations. Okay, maybe for example, you are more interested in firepower. Okay, so you can probably follow a concentration examination SNCF for firepower. Okay, where like firepower is discussed in extreme great detail, everything about firepower. Okay, CCNP Encore. Right now, what we are doing is to understand a bit of everything. Okay, the entire landscape, and of course, as you can imagine, getting into extreme code details for everything is not possible. Okay, that will take entire year to do. Okay, that is not possible. What we are trying to understand is how to get things up and running. Every device here, as you can see, is different. The way you set it up is different. The way they work is different. The way they're implemented is different, and so on and so forth. Here, we are trying to understand different things. I mean, of course, the functionalities and stuff is also overlapping somewhere here and there, but that is because Cisco has been taking over a lot of security companies every now and then. Okay. So anyway, we learn about that later on, and that is what it is, right? Now, as per the requirements that I would expect you guys to have is I would probably, I mean, I'm probably assuming that all of you at least know CCNA level stuff. Okay, I am probably hoping that everybody at least knows all the CCNA level stuff, meaning working with iOS. Okay, then these basic stuff. Okay, and it's technology. So everything that CCNA has to offer, I am probably assuming that you know all of this. Okay, probably like even ACL and NAT stuff and things like that. Okay, so I am hoping that you guys are probably aware of this. In case not, I mean, of course, get in touch with those. Anyway, this is a weekend class. You have the entire week. It will be better if you get in touch. That probably again you should know. Okay, so this is something that you probably should uh, like have the basic knowledge of. Okay, now with regards to the course, as you know that this is, I mean, of course, we're dealing with SCORE, and this is a weekend class. Okay, this is a weekend class, meaning it will be there on Saturdays and Sundays. Okay, so this will be there on Saturdays and Sundays. Okay, and I mean, we'll be of course starting at 5 p.m. sharp. Okay. The max that we will be stretching it up to is 3 hours, but that's the maximum. We'll try to wrap it up probably in like 2 to 2.5 hours. Okay, we will try to do so. Okay, depending on what the content is probably, but and depending on how devices react and stuff. So and how soon we are able to like complete the topologies and things like that. Okay, but whatever it is, we'll try to wrap it up like soon as possible. Okay. Now, although we are not very stringent on the actual duration, okay, of the entire course, this probably will take uh, 15 days or something. Okay, like this is day one, or it could be less depending on how are you able to grasp things, how well devices respond and stuff. Maybe sometimes they work slow, and sometimes there are some other issues with devices and topologies. Considering everything just goes fine, probably it can be lesser as well. Okay, it can be lesser than 15 days. I'm just taking up a buffer, probably 15, 18 days, probably, but it will be lesser. Okay, I'm assuming it will be lesser, but this is, I mean, something that I'm taking as a buffer. Okay, so probably, yeah, that way. Now, you have some things at your benefit. Please, everybody, be on the Telegram group. That is our official group, like for this class, and that will be a place where we would coordinate on things. Okay, so basic coordination and communication has to be on the Telegram group. Okay, please, everybody has to be there. Okay, otherwise we'll miss on the communication and stuff. Now, this session, for example, is being recorded. These recorded sessions are available at your disposal, right? They are, however, available on something called as a Thinkific platform. Okay, so these credentials of the platform would be there on your email. Okay, this is not something that we share as a link on the Telegram group or whatever. The Thinkific platform is where you will find these recorded sessions and stuff. So please check for the email in case you haven't got those. You can connect with Nitish sir or whosoever was in connect with you. Try to reach out to them and get the credentials, and you'll see those recorded session day wise put up there. Okay, so that is the thing. This is the whiteboard, okay, as we call it here, and this is a PPT and its link. Okay, I will share it with you as a link of it in the Telegram group. Okay, so this of course will have all the explanation and stuff, and this is like the notes thing as well for you probably, and this will have all the scribbling and those things as well, just in case you want to go through of whatever was discussed in the course, maybe in the class. Whenever I do some topologies, I will be sharing those screenshots as well. Okay, the topologies we'll be doing it is probably an EVNG. And just for a thing or so, we'll be using the Cisco DevNet sandbox. Okay, but that is just for one or more things, probably because they don't run well on EVNG. Okay, as of now, and we'll probably use like sandbox for them. Anyway, that is all something that we'll discuss later on when the time comes. But everything else, yeah, is probably on EVNG is something that we'll look into. Now, once that is done. All right. So yeah, topology is basically, so I was saying, yeah, we'll be doing it on Eve, and I'll be sharing like screenshots. Okay, so that you can like replicate. And of course, here is also where I will like I will put those screenshots here on the PPT as well. So anyway, like you will have those commands and stuff also in the PPT and things, and like something similar to that. Okay, for everything else, more or less, because a lot of things here that you will see are GUI based interfaces. Okay, for example, in the ESA, in the firepower, in the ESA, WSA, whatsoever, you generally have GUI interfaces, GUI interfaces, and I mean, of course, usually there are no commands except for some things. There are no commands and stuff. I mean, you'll have to go through the recorded session to have a better understanding of where to go and what to click and what not, and just in case if you want to revise. Other than that, however, I will be sharing with you lab guides, okay, which will have detailed instruction on how to create those labs. Okay, like how to replicate those labs is something that you'll understand in these lab guides. Now these are there in terms of PDF, and I will be sharing them on the Telegram group. Okay, so please be there on the Telegram group. If you haven't already joined, please join it. And yeah, in case you are not supposed to, you are not coming for the class, or maybe if I am delayed or something, or if there is some other communication that has to go through, it will always be the Telegram group. Okay, so please ensure that you are there. So let's understand some terminologies and some basic stuff about security that probably like the information in a very basic form that you should have. Okay, so these are some these are some terminologies that you should basically have some knowledge of. Okay, now, yeah, let's start with those. So basically, like I said, these are some terms and terminologies that we are trying to like understand with regards to security. Okay, cool. So first of all, when you have today's networks, okay, like whatever the network that you're dealing with, what you will see is these networks, you can fairly assume them to be very large and complicated and interconnected, right? So basically, like modern networks, if you say, okay, the modern networks that you say are probably like large networks, right? They are interconnected as well. Okay, so it is usually you would not really have networks that are like in one corner of the world and nobody is able to access it and stuff. That is generally not the case. Okay, the networks that you will see are pretty large and they are like well interconnected. Now, basically, because of this interconnection, what I mean is basically probably they are like connected to the internet and stuff. Okay, that is generally what uh, networks are like today. So this connection of our local network with the internet poses some problems, right? So what can happen is some malicious user can outright connect their network to ours, okay, via the internet and stuff, meaning like remotely people can attach themselves to our networks, correct? So remotely attackers can attach themselves to our network. And this, of course, poses major problems, right? Now, we also have, like with this entire network working on, we obviously commonly use TCP/IP for internet working, and it makes it easier to exploit the vulnerabilities and all of these things. And yeah, I mean, because of all of this, it is greatly necessary to have a lot of security stuff in place. If not, of course, you are basically opening up yourself to the entire internet, which is a public, of course, resource, and you can be easily be taken down. Okay, some attacker probably, depending on what their intention is, will probably take you down in case you left yourself open like that. Now, when it comes to having security, okay, when it comes to actually having security in place, what you should understand is that uh, you have to guarantee some basic parameters. Okay, for your network, you need to ensure that you uh, have these basic guarantees for your network. Okay, and these are outlined by something called as the CIA triad. Okay, now what is this? So basically, this is assumed to be like a triangle, and on one side of it is the integrity part. Okay, and there is availability, and there is something called as confidentiality. Okay, now what are these basically? So confidentiality simply means, okay, as the name suggests, confidential information. Okay, so confidentiality simply means that only authorized users can view the information or sensitive information. So only authorized users should be able to access sensitive information. Okay, so that's one thing. Confidentiality means that only authorized users should be able to view sensitive information. Okay, what else? There is integrity. Okay, so integrity here means the integrity of the information or the data that is uh, in the data traffic, okay, or in the network. Integrity means that only authorized users can change sensitive information or modify. Okay, can change or modify information. So only authorized users should be able to do that. Okay, some random users, of course, shouldn't be able to do all of these things. And finally, it is availability. Okay, now see, it is a basic misconception that people assume that let's say you have your network and there is some malicious user attacker somewhere, a black hat hacker who who wants to gain access to your network to pull out some information. Okay, which is fine. I mean, of course, that is one of the things that you should be worried about, but it is not the only thing. Okay, sometimes let's say you are some service provider for something. Okay, I don't know. You have your organization, maybe you provide servers, or maybe you have data centers, or maybe you provide some kind of service to your clients. Okay, and maybe like there is client one and client two and like, things like that. It may not be the case that this attacker or hacker just wants to gain access or steal some information. Okay, it may just be that this attacker wants to bring down your network so that you are unable to serve your clients. Okay, which of course will harm you in terms of reputation, and it will harm you in terms of uh, business revenue and things like that. Okay, so availability is also an issue. So basically, here availability simply means that there should be a guarantee of uninterrupted. Okay, there should be uninterrupted access to services. Okay, or resources, whatever you want to call it. Okay, resources, services. Okay, that those shouldn't be like down. Okay, on account of some hack or maybe some attack that has happened. That shouldn't be there. Okay. So basically, these three things are supposed to be guaranteed by your security whenever you provide them. Confidentiality, integrity, and availability is something that your network should be able to provide. Okay, what else? So there are some other terms that we'll discuss with regards to your organization and the security features that it has. Okay, now one of the things uh, that you need to understand is the term assets. Okay, so what is an asset? Asset is basically anything that is of value to your organization. Okay, asset is nothing but anything of value to the organization. Okay, meaning to your organization, it could be anything that is of value. Okay, now this can be actually your hardware. Okay, meaning the servers or maybe the information that is on it. Okay, It's anything that belongs to your organization and it holds some value. Okay, so that is called an asset. In fact, the entire job of security is to provide security to these assets. Correct? That is what the role of security is. Now, there is something called as vulnerability. Okay, so vulnerability simply means that this is a weakness in your system. Okay, in a system or a design, whatever it is a weakness. Weakness is a weakness in our case, of course, it will be probably like the network or something. But yeah, the vulnerability generally means that there is some weakness in a system. Okay, here in our case, of course, it is the network because we are dealing with network security. Now, what the attackers will do is they will exploit. Okay, now what does the exploit mean then? So basically, exploit is a method to leverage the vulnerability. Okay, so there is a vulnerability with a weakness, and the attacker or the hacker, what they will do is they will use a certain method, okay, to leverage this vulnerability. Okay, what they will do is they will leverage this vulnerability to bring down your network. There is a term which is called as a threat. A threat is basically the potential, okay, the potential danger to your network. Okay, the threat is nothing but it is an actual potential danger to the network. Okay, that is called as a threat. Now, for these things, vulnerability and the exploit and the threat, what you will do is you will deploy a countermeasure. Okay, so what you will do is you will define your or you will implement a countermeasure. This is also sometimes called as a safeguard. So basically, the countermeasure is a protection. Okay, it is a protection that reduces or mitigates a potential risk, right? So a threat, okay, basically a protection that reduces or mitigates a risk, okay, or this threat. Okay, so these are some terms that you should basically be knowing. Okay, so basically asset is nothing but anything that has value. Okay, now like I said, it can be anything. It can be a hardware, it can be a software, it can be data, it can be some other resources. These are the ones that you're actually protecting. Yeah, that is something that I mean you have to classify. In fact, sometimes you need to classify the assets as a requirement of the law. Okay, sometimes it is to demonstrate commitment to of the organization to security. Sometimes you have to identify the assets to understand their sensitivity. Okay, because not all assets would be critical. Okay, some assets would be not so critical. Okay, some assets would be very sensitive, very critical, and you need to protect those. Okay, so you have to identify and classify which assets are there, and what you will be able to do then is actually apply countermeasures accordingly. If you do not classify the threats, you will of course not be able to like do that. So assets have different values depending on your guidelines. You have to classify them. Classification may be, like I said, required by law to do. And there will be three basic benefits. Okay, whenever you classify the assets, you will be basically demonstrating your commitment as an organization to the security of these assets. You will identify the assets which are most sensitive. And finally, you will be able to understand what countermeasures are you supposed to deploy. Okay, now it comes to, yeah, so basically classification of assets is something that you need to probably do. And you'll basically be understanding, as to why is it required to classify them, because you'll understand how important these assets may be. Now, you would also be required to classify vulnerabilities. Okay, so we understood that vulnerability is nothing but a weakness in your network. But these vulnerabilities can be like a lot of things. Okay, these vulnerabilities can be a lot of things. So they can range all the way from maybe policy flaws. Okay, so some policies that you have set up, and those have some flaws. Okay, which inherently attract the attacker. There might be design flaws or design errors in your systems. There might be protocol weaknesses. Okay, so a lot of protocols are known to have bugs, and um, they have some weaknesses. Okay, so protocols may have certain weaknesses which can be exploited. Okay, uh, similar is with the softwares that you use. Okay, so possibly you have deployed some softwares, and those also have some weaknesses, right? Possibly you want to look into those. Uh, a vulnerability can also come from misconfiguration of things. Okay, so maybe you have misconfigured stuff. And there can be, of course, a host of other human factors, psychological factors, which can contribute to vulnerabilities. Okay. Now, these vulnerabilities, are sometimes like nationally stored in some databases. Okay. So, for example, the US, the United States of America, okay, the USA basically, it has its own vulnerability database. Okay. It's I think it's called as Common Vulnerability and Exposure Database or National Vulnerability Database. So this National Vulnerability Database is something that holds all the vulnerabilities, meaning people from various organizations and like stuff they contribute. They contribute to this database, and yeah, you can basically find out a lot of vulnerabilities with regards to the softwares or the brands or the things that you use. Okay, it will help you then understand what countermeasures can you deploy, and it will make possibly your working environment a little, uh, a little better. Okay, so yeah, these are basically like some things that uh, you can possibly uh, like basically use. So these databases are there. Possibly, if we have time later on, we'll also look into the database and understand uh, various like various threats and vulnerabilities that are identified generally by different organizations. So it ranges from all the way from like contributors like Apple and Microsoft and Cisco, and basically they list all the vulnerabilities and things there. Okay, so whenever they find out something, it is listed on this national database, and then maybe patches and stuff can be designed. So yeah, basically you have those like things over there. Okay, now when it comes to countermeasures, okay, when it comes to countermeasures, the countermeasures can be of different types depending on like where and what you apply. This can be administrative. Okay, so like I said, I mean, it's not only that these may be technical, right? Sometimes these are policies that your organization sets up, and which may attract the attacker to attack things, or maybe they find a blind spot somewhere and they try to go through the loophole. So countermeasures can be administrative. You can take some administrative decisions, and you can possibly counter those problems. Yeah, I mean, of course, other times it can be technical, okay, where you can deploy some technical stuff, okay, like firewalls, ASAs, and whatnot, and uh, access policies and whatnot, and you can do those things. Sometimes you just have to physically provide security, okay, to your stuff. Okay, so in your local organization where locally the servers are placed, Of course, I mean, you have to provide them under physical security, right? That is also something that you obviously need to do, without which things aren't going to, uh, well, I mean, if you have uh, if you have all the technicalities in place, but let's say your physical server is not physically secured, somebody might just come in and grab your hard drive and go away. Okay, so how is your access policy going to stop all of that? Of course not, right? So you have to, of course, physically also secure the location and stuff. That is, of course, something that you have to do. Countermeasures also can be preventive in nature. Okay, meaning uh, you want to prevent something from happening. Okay, this can be done by analyzing your network and those things. So it can be preventative, okay, or preventive, because you know that something can happen and you will deploy certain things in place. It can be detective. So meaning when something is happening, you will detect it and then apply the countermeasure. Okay, so preventive is something that you prevent. Detective is something is going wrong, you detect it and outright try to stop it or prevent from happening then. And finally, sometimes some things go wrong, okay, and which cannot be prevented or detected, and you have to then apply some corrective measure, okay, like post attack maybe. Okay, or maybe all of these three things are also in place. Okay, it is not only like one of them that you will deploy, but possibly you might decide and manage these three things all together. So there is something that you might do before the attack. There is something that you might be required to do during the attack is happening. Sometimes you will need to do something corrective after the attack has happened, depending on what your network and resources and stuff are there, right? So yeah, basically, this is something that you may need to like sort of understand. Okay, so yeah, basically that is something that you need to sort of understand. Okay, so like I said, this class, the first class at least, is gonna be like a theory thing, like where we understand some terminologies, not something complicated and stuff, but yeah, I mean, it is just good to know. Okay, it is just good to know these things and stuff. Again, these are like very basic definitions. Okay, I would call them. From tomorrow onwards, we'll begin with the lab and stuff. We'll start off with ASA and things like that. Okay. Right now, let's just understand. Anyway, this is the first day, so let's keep it to this. Uh, okay, let's understand also some other things related to something called as like managing risk. Okay, so of course you know that the risk is there. Okay, and you need to sort of manage it, right? So you have to manage risks. Okay. Now there is of course something called as a threat source. Okay, now what is a threat source? Basically, threat source is an intent. Okay, it is an intent and method that is targeted at the intentional exploitation of a vulnerability. So threat source is nothing but it is a method, you could say. So what is my threat source? A threat source is a method that is targeted at the intentional exploitation. So method basically exploiting. Okay, so that is called as a threat source, a vulnerability. Now, threat in general is the potential, as we discussed, right? So we discussed the threat thing. So threat is basically like a potential danger to any of my systems or networks in place. You know what vulnerability is. There is also something which is called as the attack surface. Okay, now, what is an attack surface? So basically, attack surface is the total sum of vulnerabilities in a given system. Okay, the total attack surface is the total sum, okay, of all the vulnerabilities in your system. Okay, in your system, it is all the all the vulnerabilities put together. This is totally this is called as the total attack surface. Okay, and finally, there will be some impact, right? Out of all of this, there will be certain impact. Now, what do you mean by impact? Impact is the resulting damage. Okay, this is like the resulting damage out of that threat. Okay, resulting from that, or let's say caused by the threat. Okay, so threat is the potential, but finally, when it actualizes, okay, the resulting damage is called as the impact. Now this impact thing, okay, is, I mean, of course, it is the actual damage that has been caused by some attack. Okay, so all in all, if you were to say like what is the final risk in your system? So risk is nothing but it is something that is equal to threats. Okay, so whatever the threats are in your network, it times the vulnerabilities, okay, times the impact, okay, whatever impact can happen. So the total risk to your organization is the number of threats times the vulnerabilities that you have times the impact that you have or can have, you know, as a result. And all of these put together is something which is called as a risk to your organization. Okay, so this is basically like the total risk to your organization. This is like the entire thing. So what else? Okay, so with all these things in place, the risk management and whatnot, so how would you then manage all of this? Okay, so that falls under something called as risk management. Okay, now what is this? So risk management has some things involved. Okay, now one of those is something called as risk acceptance. Okay, now what this means is that you're willing to accept the risk. Now, yeah, weirdly as it seems, it is sometimes the like the option. Okay, because you know there is some risk. Okay, so let's say you have your network and there is some risk that you know that is there in the network. There is some risk in your network, but you will assess it, and finally, let's say, you know, the impact of it is not great enough. Okay, but to get rid of this risk, okay, possibly the cost that you will need to put in is too high. In that case, of course, it is, you're not going to deploy. I mean, you're not trying to go, like, you're not going to try to evade this risk because it does not make sense. Okay, because the cost is too much, the impact is too less, even if it is like exploited someday. Uh, Possibly like it's not required, right? So sometimes risk acceptance is sometimes that you need to accept it, meaning like, okay, fine, this risk is there, but the impact is not going to be much. In fact, if I try to like get rid of it, the cost is going to be too high. I mean, of course, in real organizations, you have to consider like various things. So yeah, sometimes risk acceptance is a common option. Okay, it's a common option uh, when the let's say when the cost of avoidance. Okay, so let's say like uh, when avoidance probably, okay, when you want to probably avoid, so you want to let's say you want to put up an avoidance mechanism, but the cost is too much. Okay, it really doesn't make sense. Okay, so avoidance costs, okay, they will outweigh the cost of risk itself. Okay, so when the avoidance costs, they outweigh the cost of risk itself, and it doesn't really like make a lot of sense to uh, so it is not necessary that every risk that you know of should be avoided, because that may not be required. Okay, not everything will have a deep impact, but again, it is dependent on what your network is, what your resources are, how critical things are something that you're protecting. Okay, it depends. Okay, it is not a one-way thing. It is not a simple thing to understand. I mean, of course, everything requires analysis, right? So you'll have to analyze things and then have to decide whether it can be accepted or not. So, but anyway, risk acceptance is one of those things that you can clearly think of. The other thing, as you can clearly imagine, which is kind of very common thing, is of course you want to avoid a certain risk. Okay, so risk avoidance basically is the action that avoids any exposure to the risk. Okay, so here is where you will avoid exposure to the risk. Okay, so what you will do is you will avoid, as I mean, like as commonly as you can think of. I mean, whenever there is a risk, you will try to avoid it, right? Only, yeah, in some cases it doesn't make a lot of sense, and you will then decide to accept it. Okay, that is basically like what that is. So risk avoidance is, yeah, whenever you do that, okay, in terms of cost, in terms of uh, like in terms of implementation and things like that, this is the most expensive stuff. Okay, this is going to be the most expensive thing that you will deploy in terms of, so it's not only the monetary cost, it can be manpower, it can be man hours, it can be time, it can be complexity. Whenever you try to completely avoid a risk, please do note that it will be the most expensive in whatever you consider it, okay, in terms of actual cost or maybe time hours or whatever. Okay, so risk avoidance is something that you can, of course, think of. Sometimes it can be risk limitation. Okay, so sometimes there can be risk limitations where you basically limit the risk. Okay, you're not completely avoiding it, but you're trying to limit the risk or the exposure to the risk. Okay, now this is a strategy so this is a combination. Okay, like it is a combination of both risk acceptance and a bit of avoidance. Okay, so you're trying to do both in a way. You are trying to like have acceptance, and you're also trying to avoid it in a certain way, but not completely. Okay, so that is called as limitation. You're basically trying to limit the risk, not completely avoiding it. So the first thing that we saw was completely accepting the risk, meaning you're doing nothing. Risk avoidance is like doing everything. Okay, and that is why it is the like most expensive. Risk limitation is somewhere in between, right? You're not completely avoiding it, you're not completely accepting it, but you are sort of limiting it. Okay, that okay, we'll like bring it to this point and possibly uh, like let's try to bear the brunt a little. Okay, but not completely. Finally, one last weird thing is risk transfer. Okay, so what you can do is you can have a risk transfer. Now, this is a little weird. Okay, so what this means is that you're transferring this to a third party. Okay, so you're transferring this, or you're willing to transfer the risk. Okay, what that simply means is you choose to have the risk. Okay, and however, it is covered by, let's say, some insurance of yours. Okay, example is like you are insured for something. Okay, and let's say you are attacked or some theft, that something happens and things like that, but then you are, because you're insured, you're not really worried about it. Okay, what you have done in that case, you have transferred the risk to a third party, in your case the insurance company. Okay, so these are the four types of risk management stuff. This is where you can like actually go about like these are the steps that you can understand and think about when it comes to risk management. These are the four possibilities. Basically, when you think about it, it just seems like yeah, risk avoidance is like only the way to go. Certainly, of course, that is not the only thing that you can do. You can do a lot of things other than that as well. Okay, so yeah, this is basically all about risk management. Okay, now like so, there is also something called as vulnerability assessment. Okay, so if you remember our conversation from earlier, vulnerability is weakness. Okay, so what you are trying to assess is the weakness in the systems, correct? So vulnerability assessment is something that, of course, you should do. Okay, now basically what this is in general, like generally in like in our infrastructure and stuff, this is like a defect in some hardware or software, and when this is paired with some exploit. Okay, so basically, I mean, of course, nothing is perfect. Possibly your software that you use, okay, or the hardware that you use. Okay, they will have some defects, of course, some security flaws or something like that. And then what happens is when this is like when this defect, is paired with some exploit. Okay, so there will be somebody who's going to go ahead and exploit this defect. Okay, then it becomes a problem. Then it becomes a proper vulnerability. It becomes a threat to our organization. So yeah, basically, this is what vulnerability is. Okay, so there may be some defect when it is somebody tries to use it against you. It becomes a proper vulnerability. Now, assessment, of course, is to ensure that the network and the and your systems basically are tested for vulnerabilities. Okay, so early on in your network, what you would be required to do is assess your network. Okay, so it can be a lot of things. Okay, what you can do is you can maybe you want to deal with device discovery. Okay, so what you can do is in your organization you can understand if the devices are discoverable. Okay, when I say device discovery, it can be through a host of things. Okay, like whether they can be identified from outside the network. Okay, in terms of host names, in terms of IP addresses, whether they can be whether they can be pinged from outside. Okay, even just basic pinging can reveal a lot of information if they are allowed to ping. Okay, maybe you want to scan it in terms of TCP. Okay, TCP synchronize sync scanning, that is called basically. So TCP syn scan, if it allows your devices, are they allowing it? Okay, maybe you want to deal with service enumeration. Okay, so in terms of services, whether somebody can from outside can scan your TCP or UDP ports. Okay, so or the web services that you're providing. Okay, so maybe you want to do that. Maybe you want to scan for other things. Okay, so yeah, I mean, yeah, these are all the basic stuff: defined discovery and services. I mean, that is something that you can basically imagine. But there you can also look out for scanning other things. Okay, so you might require to scan your network for configuration issues. Okay, maybe they are not configured well. So you know about configuration, right? You can configure things in simple manner. You can configure things in a very secured manner. Okay, so maybe there are configuration issues itself. Okay, so you might need to scan for those. Maybe the patches and stuff are there. Okay, but you haven't in your network installed those. Okay, so the patches are missing. Okay, you know that whenever you make things or whenever you deploy things, there are always patches that the companies release. Okay, but maybe you guys haven't installed them in your network. Okay, and maybe apart from all of this, you have some other dangerous services which are just running. Okay, nobody has taken the time to turn them off. Okay, the ports are open or things like that, and maybe like that. So yeah, basically these are some things that you can look for and you can assess your vulnerabilities. Okay, in your organization. Okay, so yeah, these are some things that you can look into. Now, you know that the network that we use. Okay, the network that we use, I mean, of course, it relies on itself. When I say like the proper internet working and stuff like that, we of course sort of use like the TCP/IP model. Okay, and these TCP/IP stuff have their own vulnerabilities. Okay, okay, so this TCP/IP stuff has its own vulnerabilities, and you know that within like the TCP/IP stuff, you use IP protocol. Okay, meaning the IP address and stuff. You have the TCP, you have the UDP, and basically the streaming service. Okay, the ICMP, sorry, right? So these are some very basic four common protocols that you might be using in your network, and it is necessary to uh, check for vulnerabilities with these things. Okay, with the IP that you're using, the TCP, UDP protocols, with the ICMP that you are allowing. Okay, so you need to sort of look into all of these. Okay, so yeah, these are some things that you need to check. But however, like specifically saying what can be these vulnerabilities? Okay, when I say TCP/IP vulnerabilities, what can these things be? So one of these things that can be is something called as MITM attack. Okay, now what is MITM attack? MITM attack is simply man in the middle attack. Okay, now what is man in the middle attack? So man in the middle attack, what it assumes is like there is somebody intercepting your communication. Okay, so let's say you have your device, let's say A, which is like a genuine device of yours, and there is like a device B, which is a genuine device of yours, and they are supposed to like let's say communicate with one another. Okay, these are two genuine devices, but somebody what they do is they have their own device, let's say C, and this hacker guy, okay, this guy sits in the middle and they intercept your communication. Okay, so this guy is like a man in the middle. Okay, they intercept the communication between your two systems, and of course, this I mean it's not just intercepting it. It can be a lot of things related to this, but yeah, we will discuss that in a bit. Okay, so it basically like intercepts the community. Now, MITM is just fine. Okay, there might be somebody just listening to your communication, which is of course can be a real problem if you are using plain text stuff. Okay, in terms of security, if you are not encrypting stuff, if you are not looking into encryption decryption stuff, and this attacker can basically look into your packets, and a lot of information can be gathered anyway. Okay, so that is one thing, but this can be far more devastating if if this MITM person employs something called as session hijacking. Okay, so in session hijacking, what happens is, apart from just sitting in the middle, okay, so this is like a twist on the MITM attack. What happens is the attacker basically gains physical access to the network, okay, and he basically initiates an MITM attack and hijacks the session. Okay, so for example, let's say A and B are having like a communication, and what this guy will pose C as, he will like masquerade as the APC. Okay, and he will then communicate with the B device as if it was device A. Okay, so the session is basically hijacked. Okay, so it is like a twist on the MITM attack where the attacker gains. So here the attacker actually gains access to the session. Now, one of the common things that the IP vulnerability can have is IP spoofing. Okay, so somebody can just spoof your address. Okay, spoof your address meaning like put up a fake address, right? Okay, so IP spoofing is a very common thing, meaning somebody will fake their IP address and send the packets. Okay, generally what happens is that whenever you are a device, okay, and whenever you send out like packets and stuff, of course, it is your own IP address that is being used as a source, right? But in IP spoofing, what happens is the attacker does not use his own IP address or its IP address. What they use is some spoofed IP address, right? So spoofing can take place. Okay, attackers will spoof addresses, and as you can imagine, if you have stateless filtering, okay, for example, like ACLs and stuff, this will simply allow the packet inside, right? Because the IP address is something that it is proving to be genuine. Okay, so the attackers here spoof the addresses. Okay, spoof the source IP address particularly, of course. Okay, so they basically put up a spoofed IP address in their source, not the actual IP address that they have. And I mean, of course, this can do a lot of devastating stuff. Okay, this can simply allow you access inside your network, and it will not be questioned. Right, so that is one thing that can happen here in TCP/IP networks. Again, what else? So a very common thing that you might have heard of even, okay, because it's a very common type of an attack. This is basically the DOS attack. Okay, DOS is denial of service. Okay, so DOS attack, what happens is you prevent some network or some server to not be able to do its job, or they shouldn't be able to provide their services. Okay, so let's say this is some ABC network. Okay, and their job role is to provide access to the server, and maybe I don't know, so some services provided by the server. Now, if you want to bring it down, what you can do is you can have a denial of attack service be launched on this server or this network. What this will do is it will bombard it with such a lot of information that this network isn't able to process it. Okay. What will happen is there will be so much of information coming on onto the server so that it is overloaded. And of course, these requests are all false requests. Okay. These are just fake requests, but they are so many. Okay. There are so many, and it bombards this server or this network, finally making this network go down because it is not able to do anything else. It is just catering to these requests, these fake requests, and they seem genuine. Okay, they seem genuine to the server, so it is basically processing all of those. But finally, because of all of that processing, it has no capacity to do anything else, and it finally goes down. Okay, so that is basically like what happens in a DOS attack. Okay, so you basically flood the resources. Okay, it can be anything. There can be a lot of things basically, but yeah, basically you flood the resources of the victim network, so much so that it finally goes down. Now, this was earlier just the DOS attack. Nowadays, this has transformed into something called as DDoS attacks. Okay, now this has transformed into something still more deadly, which is called as distributed denial of attack, denial of service attacks. So now this is no longer restricted to being one single device. So earlier what happened was the attacker was sitting in one place, okay, and this attacker guy was sending out all these fake requests, okay. So this attacker guy will constantly go on bombarding with your victim network with so many requests and stuff. Okay, that has basically transformed into something called as distributed denial of service attack. Now what happens is, first your attacker, what they do is they create a botnet. Okay, now what is a botnet? A botnet is a sequence of, or like a collection of victim devices, okay, which act like zombies. Okay, so these are your zombie PCs or zombie devices. The attacker first infects these zombie devices, okay, and then these zombie devices attack the victim unknowingly, okay, meaning they are not actually colluding with the attacker. Okay, they are not doing that. They don't even know the attacker. So these zombies are also victims. Okay, but these victims will launch unknowingly an attack on the victim network. Okay, and they will flood this network or the server with so many requests such that it of course goes down. Okay, the funda is same. Okay, the fundamental is still the same. What you're doing is you are still flooding the resources of the, okay, you're still flooding the resources of the victim network. But who's doing that? Okay, the attack is basically launched not from the attacker itself. Okay, the attack is launched from botnets. Okay, so the attack is launched from botnets, and they are also victims. Okay, they don't know that they're launching an attack. Okay, so the attack is basically launched from botnets across the internet. And at a certain trigger, at some date maybe or something like that, they will launch an attack altogether. Okay, so these zombies are not something that, they're not pairing up with the attacker. Okay, that is not the case. These are also victims. Okay, but they have been infected and they are waiting for the instruction. And whenever there's an instruction, they will like go through. Okay, they will take out the device. Okay, so this is the attacker here. They first infect the botnet. Okay, botnets are like many different PCs all across the internet or devices, maybe whatever devices they can be. And all of them will launch a directed attack towards your whatever the network, abc.com, let's say. And they'll bring down the victim network. Okay, that is what happens.